Good morning, all of you. So, last class we were discussing about the chapter parallel lines. So, we have studied more thing about the parallel line. So, the main concept you studied that two or more parallel lines can cut the any two lines in the same ratio. So, same way that concept we can use for the triangle division also. Triangle also, when you divide by the parallel line, the same ratio you can see for the sides also. So, we have done many diagrams also how to divide a given line in the given ratio. That all you have studied. Now we are moving on to the last topic that we'll see now. You have a triangle here, and from the one vertex you are drawing a line to the opposite side. From the one vertex you are drawing a line to the opposite side. So the same I'm doing with every vertex. From this point I'm drawing another line to the opposite vertex. From this point I'm drawing the line to the opposite side. So there are three lines you can see. So these lines are called median. So this is that line is called median. From the one vertex to the opposite side you are drawing one line. Same way from here also I'm drawing another line to the opposite side. So three lines you will get. So those three lines are called medians. So these medians intersect at a single point. That point is called centroid. The point of intersection of the medians is called the centroid of the triangle. So center of this triangle will be this one. And also one concept you can see here, any triangle, all the medians intersect at a single point. At that point divides each median in the ratio 2:1. That means here you have a median. So whenever this also median, this also median. So this is intersect at this point. In that case, it will divide in the ratio of 2:1. So the larger line will be 2 and the smaller line will be 1. Means it's the ratio, not the number. It can be 10, 5, like that. So ratio will be 2:1. Here also you can see, if I take this one, the larger one will be 2, smaller one will be 1. And larger one will be 2, smaller one will be 1. So like that it is dividing 2:1 ratio. So that all the medians, when it join at a single point, that point is called centroid of the triangle. We move on to the problem, page number 94, question number 3. In the parallelogram ABCD, you can see the figure. In the parallelogram ABCD, the line drawn through a point P on AB, line drawn through point P on AB, this one PQ line, parallel to BC. This line is parallel to BC, meets AC at Q, meets AC at Q. So this line is meeting at Q on the line AC. The line through Q parallel to AB. The line through Q parallel to AB meets AD at R. This line is meeting at R here. Like that given. Now prove that AB by PB is equal to AR by RD. Means AP by PB is equal to AR by RD. That is the proof you have to do. So before doing all those things, see the question, what you have to prove? That you have to write. We need to prove that. PT means prove that, okay? We need to prove that AP by PB is equal to AR by RD. This is actually the question. So that means at the end, you should get the answer as this. At the end, your answer should be this one at the end. So, what is given in the question? That you have to write. Given, no? Given ABCD is a parallelogram. That all we are copying from the question itself. ABCD is a parallelogram. If that is a parallelogram, you all know AB is parallel to CD, right? AB is parallel to DC or CD, and AD is parallel to CB. That you can write anyway. Now, what I am going to do, we have studied about the parallel lines, and also triangle division is studied. Triangle division means through the triangle you can draw the parallel line so that the side will be divided in the same ratio. Now, by the triangle division, you can see this is one triangle. You are getting, this is one triangle. That is triangle ADC. In triangle ADC, and the second triangle is here, okay, ABC. So first triangle, you can see that this is a parallel line is going. In this triangle, this is a parallel line is going. So that what will be the ratio of the sides becomes AR by RD. Means AR is to RD. We have said no, AR is to RD. So that we can write it as AR divided by RD. So in a triangle ADC, AR divided by RD is equal to, in this triangle, okay, in this triangle, so this side over, now we are going to take this side, AQ by QC, AQ is to QC, AQ by QC, what we did, AR by RD, AQ by QC, that is equation 1. because that we got from the first triangle. Now we are going to do the second triangle, triangle ABC. In triangle ABC, the same way we have to do. What is the, you have ABC triangle is this. So sides are here. So AQ by QC, or I can say, okay, AQ by QC, AQ by QC. This is the side AQ by QC, and other side which one? AP by PB. This you are getting by triangle division. Okay, you have studied that the sides ratio will be same by drawing the parallel line. So AQ by QC, AP by PB. What you did? First triangle you have taken this, second triangle you have taken this. In the first triangle, AR by RD, AQ by QC. First triangle over, second triangle, AQ by QC, AP by PB. Those will be equal. So you have to put the equation number 2. Now from equation 1 and 2, what do you get here? Here you can see AR by RD is equal to AQ by QC, AQ by QC is equal to AP by PB. That means you can see AQ by QC here also, and you can see the same thing here also, AQ by QC. That means one value you have, the same value will be equal to this, and the same value will be equal to this, no? That means what? AR by RD should be equal to AP by PB, no? So that is your proof. AR by RD is equal to AP by PB. That is AR by RD is equal to AP by PB. But in question, they have said AP by PB is equal to AR by RD. The same AP by PB is equal to AR by RD. You can just change the places. So this is the proof. Now we'll move on to the next chapter, that is chapter number 7, similar triangles. Similar triangle, that is the last chapter of the part first textbook. Okay. So this is our last chapter. So we're going to see what you mean by similar triangles. So you might have seen equal triangles last year, 8th standard. Equal triangles means what? You have studied that if two triangles, if you have all the three angles of those two triangles are equal, then we can say those triangles are equal. Or many concepts you studied there. If all the three sides are equal of those two triangles, then the two triangles will be equal. Or if two angles and one side, or one side and two angles, if they are equal, those triangles will be equal. You have studied. But here it is not equal triangles, but it is a similar triangles. How we can say it is a similar? If the two triangles are given, we have to say whether it is similar or not. So similar means the triangles will be, one bigger will be there, one smaller will be there. So by looking only you can understand it is not equal, but you have to check out whether it is similar or not. So for example, you have given two triangles here, one smaller and one bigger. But you can see the angles 40 degree, 60 degree, 80 degree. You can see the same, no? 40 degree, 60 degree, 80 degree. So angles are same. But by looking at the triangle, you can understand it is not a equal triangle because it is a small triangle. This is a bigger triangle. But we can say it is a similar triangle. How can we say by looking at this it is a similar triangle? So just to read this, in triangles with the same angles, same angle 40, 80, 60, 40, 80, 60, sides opposite to equal angles, side opposite to equal angles, which means side opposite to equal angles, side opposite to 40 degree, side opposite to 40 degree, side opposite to 60 degree, side opposite to 60 degree, side opposite to 80 degree, side opposite to 80 degree angles are scaled by the same factor. Side opposite to the equal angles are scaled by same factor. That is nothing but you have here 2 centimeter, 3 centimeter, 4 centimeter. Now you can see here, but these two sides are missing here. Only one side is given, that is 6. Actually, what is that 6? How we can compare here? 6 is opposite to 80, no? So you have to see opposite of 80, how much here? Opposite of 86, opposite of 83. So 3 and 6 will have some connection. That is 3, how much are 6? We have to see. You know that 3 2s are 6. 3 2s are 6. So you understood that something you multiplied here. That is into 2 you made. That time you got 6. That is actually are scaled by same factor. So same factor means here the 2 is a factor here. Means you multiply by 2. So the same factor they told us. So same number have to multiply here, have to multiply here. So that you will get the two sides. So like that, if you get the same number everywhere, then those two triangles will be similar. So 3 2s are 6, no? So I can say here 4 2s are. So this is the same factor I'm multiplying. 4 2s are. That is where should be 40, opposite of 40 only. You should not change the angles. Opposite of 40, 4 2s are 8. Now, which is remaining? Opposite of 60. Opposite of 60, how much is this? 2. So, 2 into 2, because you multiplied 2 everywhere. So, 2 2s are 4. So, like this you got. Now, you can say these two triangles are similar. Why? It is scaled by same factor. Same factor is which one here? 2. 2. 2 multiplied by 2. It not only 2, it can be 3, it can be fractions also. 1 by 2 can be, it can be 3 by 2 also, whatever. The fractions also can come. Whichever the numbers are multiplying here, no, that is a same factor, and that way you can understand that these two triangles are similar triangles. We will move on to the problem, page number 100. You have the first question. You can see one triangle there. The perpendicular from the square corner of a right triangle. Perpendicular from the square corner. Square corner means where the 90 degree you have. This is the 90 degree of this right triangle. This is the right triangle. 90 degree here. From there, one perpendicular line drawn cuts the opposite side into two parts. Cuts the opposite side into two parts. That is 2 and 3 centimeter length. This much is 2. This much is 3. Prove that two small right triangles cut by the perpendicular have the same angle. After cutting this, you are getting one triangle and the triangle here. So after cutting that, you are getting two triangles. So those two triangles have the same angles you have to prove. This same three angles you have, angles only you will get from here also. So those two triangles will have the same angle you have to prove. How can you prove? So you don't have the name, you have to give A, B, C, D like this. Perpendicular line means you know that when you draw, you will get a 90 degree here, 90 degrees here. So one angle already got here. Because the perpendicular line, it forms 90 degree here each. So one angle of this 90 degree, one angle of this 90 degree we got. So before finding all those, we can consider the bigger triangle ABC. So in ABC, you can see in ABC this A is 90 degree. In ABC, A is 90 degree. So I don't know B is what, but we can take it as X degree. So this is I'm taking as X degree. So B is X degree. Then B is X degree, A is 90 degree. What will be your C? So for example, if I do this is 90 degree and if this is 30 degree, this is missing. How you are doing that? That is 90, this is 90, and also you know that when you add these two, you should get 90, right? This is 90, and also when you add this two, you have to get 90. So to get this one, what you are doing? 90 minus 30. 90 minus 30, if you do, you will get the 0, 60. 60 you will get here. Or else you are doing 180 minus you are minusing this one, you will get the remaining. So that, otherwise this is 1 is 90. So you know that other two angles when you add, you are getting 90. So from the 90, 30 minusing, you will get 60. Same way, from the 90, if you minus x, you will get C, no? So C will be 90 minus x, as you did here, 90 minus 30, 90 minus x you will get. Now that much you will get, so 90 minus x. So you just to see your triangle ABD and ADC, in that you are getting one angle 90 degree and the 90 degree here, and in ABD 90 degree over, another one X degree over, third one is missing. So in ADC 90 degree over, 90 minus X degree over, third one is missing. So that angle you have to find out. So ABD, in ABD, which all given, we have to write ABD, means angle B is X, that we have written, and angle BAD, that is this one you have to find out. That is just now we found, no, 90 and X. So which remaining, which will be 90 minus X. 90 minus X you will get. Now we are moving to the ADC. Triangle ADC, which you know, this is 90 already, that you no need of writing. Angle C is 90 minus X. Now, angle DAC, that is this one. How to find out that? 90 minus X you have, so that this how to find out? This minus, you don't know, 90 minus the other number. So, 90 minus, finding DAC by 90 minus the other angle, how much you have? 90 minus X. So when you write, you have to put the bracket. When you add these two, you should get 90. So that 90 minus X, you will get it as 90 minus will go inside, okay? So minus 90. So minus becomes plus X. So that 90 minus 0. So remaining X degree. So that this is angle will be X degree. That means you got ABD triangle and ADC triangle same angles you got. In ABD 90 you have, in ADC 90 you have, in ABD x degree you have, in this triangle x degree you have, in this triangle 90 minus x you have, in this triangle 90 minus x you have. Therefore, you conclusion is therefore all the angles are same. The second sub question, the same question continues. Taking the length of the perpendiculars as h, perpendicular we can take it as h. Prove that h by 2 is equal to 3 by h. Prove that h by 2 is equal to 3 by h. That is the proof you have to do. So, you have a triangle and you have found that these two triangles are angles have the same angles. These two triangles have same angles you found, and the perpendicular line they told to take it as h. So what we are going to do is we have to check out whether similar. Similar we have found that. So triangle first one ABD, triangle ADC you have to consider. Now, okay, here 2 you have 3. That is what you have to prove. H by 2 is equal to 3 by h. That you have to prove. Now in ADC and ABD separately, in ADC triangle, x degree, I am taking x degree. X degree is opposite what you have. X degree is opposite what you have. 3. That I am writing. ADC, in ADC triangle, x degree is opposite 3 you have, and x degree is opposite in ABD. In ABD, x degree is opposite what you have. H you have. Comma I can put. Now 90 minus x degree is there, no? 90 minus x degree, that is in ADC. ADC 90 minus x degree is opposite what you have. H. Comma. In ABD 90 minus x is opposite what you have. 2. So like this you made. So that means you have said that it is a similar triangle because opposite angles, equal angles, opposite sides will have the same ratio. Now 3 and h you got, so that we can write it as 3 by h. 3 by h is equal to, we study that same ratio, it will have same ratio. So 3 by h is equal to h by 2. H by 2. Got this way. In a proof, just replace this one. Change places. H by 2 is equal to 3 by h. So both are same. Now we'll move on to the third sub question. Calculate the perpendicular sides of the large triangle. So large triangle you have ABC. Large triangle perpendicular sides means the 90 degree where it is forming, those sides are the perpendicular sides. So AC and AB you need to find out in the large triangle. So here you can see that ABC you have a large triangle. AB and AC you need to find out. For that you have divided by the perpendicular line like this, and if you use that, you after drawing the line, you got the two small triangles. So using this two smaller triangles, you can find out this side and this side. So for that, whether you know h is how much, you don't know. We just given perpendicular line as h. And also previous question we have found that one proof, h by 2 is equal to 3 by h. So that you have to use here. We got means previously we got h by 2 is equal to 3 by h. From that you can find out the value of h. Cross multiply. H into h is equal to 2 into 3. H into h means h square. H square is equal to 2 into 3, 6. So that h will be, square is going that side, square root 6. So this will be your square root of 6. H is square root of 6. Now you can take ABD triangle. ABD triangle, in that AB you can find out, that is a hypotenuse, is equal to RT square plus base square. So AB square is equal to AD square plus BD square. AD how much here? AD root 6 whole square. Root 6 whole square plus BD 2 square. Root and square will cancel. 6 plus 4, 10 you will get. And AB square is 10. Now but AB will be, square is going that side as square root. So AB getting a square root of 10. Square root of 10 you got. Now we are moving on to the other triangle ADC. In that AC is the hypotenuse. This is the altitude. This is the base. So hypotenuse square is equal to altitude square plus base square. AC square is equal to AD square plus DC square is equal to AD how much? AD is root 6 whole square, DC 3 square, square root and square cancel, 6 plus 9, 15, that is AC square is 15, AC will be root 15. So AC will be root 15 you will get. So you got no perpendicular sides measurements you got. Now we'll move on to the sub question 4. Sub question 4 is what? Prove that if the perpendicular from the square corner of the right triangle divides the opposite side into the parts of length A and B, if the length of the perpendicular is h, then h square is equal to AB. That means the same diagram, what they said, perpendicular line, if we divide like that, and it will divide this triangle into, before given 2 cm and 3 cm, but here now they are saying they can divide into A and B. Instead of 2 and 3, I am writing here A and B. The same triangle I am taking, all the angles all will be equal. This divided part will be A and this one divided part will be B, and they told the perpendicular line is H only taking. Then you have to prove H square is equal to AB. H square is equal to AB. So previously one proof you did, what is that? H by 2 is equal to 3 by H. That only you have to take. Already we have proved that H by 2 is equal to 3 by H. So instead of this 2 and 3, instead of 2, what you have here? A. So H by A is equal to, instead of 3, what you have here? B. B by H. Now what you do? Cross multiply. The same way you did here. Cross multiply, that is H into H, H square is equal to A into B. So this is the proof now. H square is equal to A into B. H square is equal to A into B. Now we'll move on to the page number 101, question number 4. You have the one picture here, one triangle, and that one square also you can see. The picture shows a square drawn sharing one corner with the right triangle, sharing one corner with the right triangle, and other 3 corners on the side of this triangle. Other 3 corners you can see on the side of this triangle. Now first question, calculate the length of a side of the square. Calculate the length of the side of the square. Square's length you have to find out. That is the first question. Second question we will do later. Now, what are the things given here? This AP given 2. We can give the name ABC triangle and PQR. This is a square, and this side is given 2 cm and the small side is given 1 cm. But the square side is not given, and the angle also not given. So you can see here, you can see the 2 triangles, somewhat similar, looking similar, 2 triangles you can see. Now we want to see whether they are similar or not. Similar, how we can say? If the 3 angles are equal, then we can say they are similar. Now, you can see this is a 90 degree forming because it's the perpendicular line, no? It is a 90 degree and this is also 90 degree. And what about this angle and this angle? That is, you can see in a parallel line, if you draw one line, you can see the angle forming here and here, they will be same. There is a corresponding angle. On the parallel line, if you cut one line, you will get the corresponding angle up and here, up above this line. So those you can see here, this angle and this angle, because this is a parallel line. This is one parallel line, this is another parallel line. One line is going this way. This one and this one are corresponding angle like this. So I don't know what is the angle, so I am taking as A degree. Here also I can take it as A degree because they are equal. Now same procedure if I use here, you can take, if 9 degree, A degree, 9 degree, A degree. Automatically the third one will be equal. That I can take it as B degree and B degree. Now, so we understood that those are similar triangles. So we have to take this first triangle and the second triangle. Now I am taking triangle APQ, triangle RQC I am taking. Now first triangle which I am taking A degree. So A degree is opposite to what you have 2. In this triangle, APQ triangle, A degree is opposite will be 2. RQC, in RQC, A degree is opposite what you have? X. X we are taking because we don't know the length of the square. If it is unknown, we are taking X. So A degree is opposite will be X. So A degree is opposite here 2. A degree is opposite will be X. So 2, X I am taking. Now B degree opposite I want. In this triangle APQ, B degree opposite what? X. And RQC, in this triangle B degree is opposite what? 1. So this is the way we are doing, like last problem we did. Ratios are same now here, so this can be written as 2 by x is equal to x by 1, like this. Okay, this is one bracket. 2 by x is equal to x by 1, so that you can cross multiply. 2 into 1 is equal to x square. X into x will be x square, so that can be written as x square is equal to 2. 2 into 1, 2. So now x is what? Square root of 2. So squares one side you got square root of 2 centimeters. Square root of 2, square root of 2, square root of 2, square root of 2. So question 2. What is the length of a side of the square drawn like this? So you have a triangle and the square the same way. That time also you have to find out the length of the side of the square. Within the triangle of side 3, 4, 5 centimeter. So before we have not given the side of the triangle, but here they are giving the side of the triangle. This is 4, this is 3 and this is 5. So it's not mentioned in the figure, but you have to understand that smaller side will be 3 and the next larger will be 4 and the largest one will be hypotenuse, that is 5. That you have to understand and you have to draw. So what is the length of the side of the square? So in this case, what happens for the length of the side of the square? Same way what we did before, same way. But here, this was not given, the full is given 4. This full is given 3, full is given 5. This side we don't want because we need only these two sides. So, we told that these two triangles are similar. So, just take the triangles here. And before that, 4 and this part is x, no. So, what will be remaining? This one, this will be 4 minus x. This remaining part will be 4 minus x, and here also 3, full is 3, this much is x, remaining part will be 3 minus x, here will be 3 minus x, that is the changes here. Now the triangle APQ, in that opposite of A degree, what you have? 4 minus x, comma, next RQC, in that opposite of A degree, what you have? X. Now same APQ, opposite of B degree, x you have. RQC, opposite of B degree, 3 minus x you have. Now you have to find out the x value. X value means one side of the square. Now this becomes, what happens? 4 minus x divided by x, this x, okay, is equal to x divided by 3 minus x. So what happens here? You have to cross multiply. X into x will be x square is equal to 4 minus x into 3 minus x. That you have to multiply with every number, first number, second number, like this you have to multiply. So x square is equal to, see the arrow mark, 4 into 3, 12. 4 into 3, 12. Next this 4 into x, 4x, and here minus you have, minus 4x. Next this one, minus x into 3, that is minus 3x. Means 3 into x is 3x and the sign is minus. Next this number with the last number, x into x is square, but minus becomes plus x square. Now when I bring this x square this side, x square plus x square becomes minus x square, that time it will be 0. It will be 0. So what happens here? So this side nothing is there, no, so 0 I am putting. 12 minus 4x minus 3x. Whenever you have the same sign, you have to add that. 4x plus 3x, 7x. And the sign is both the signs are negative, no? So minus 7x. So 12 minus 7 is equal to 0. So what I can do is, this I can bring this side, no? 7x I am bringing here. So that minus becomes positive. 7x is equal to 12. Nothing I did. 12 I am keeping here, 7x bringing here. So minus 7x becomes positive. So now x is equal to 12 by 7. 12 by 7. Divide 12 by 7. 7 ones are 5 you will get, remainder 5. 5 cannot divide, so put a point and put a 0. 7 sevens are 49. So 1 is going on, so this much enough, 1.7 centimeter. So this is the answer for one side of your square, 1.7 centimeter.